Good evening, viewers. Recently, I met with an accident. That's why I cannot able to take the video classes. Okay, now I'm all right. I'm recouping from my accident, and now I'm telling you this the video class. Today, I'm going to take you about this probability. The word probability is very commonly used in day-to-day conversation. In layman's terminology, the word probability connotes that there is uncertainty about What has happened. In statistical sense, the term probability is thus established by definition, and it is not connected connected with beliefs or any form of willful thinking. Now, when you take into account the probability definition, the probability of a given event is an expression of likelihood of occurrences of an event. A probability is a number which ranges from 0 to 1, 0 for an event which cannot occur and 1 for an event which can certain to occur. Broadly speaking, there are four different schools of thought on the concept of probability. First one is classical or prior probability. Second one is relative frequency theory of probability. Third one is personalistic view of probability. And fourth one, that is the last one, is axiomatic theory approach to probability. Now, classical or a priori probability. It is the oldest and simplest one. The basic assumption underlying the classical theory is that the outcomes of a random experiment are equally likely. The event whose probability is sought consists of one or more possible outcomes of the given activity. These activities are referred to in modern terminology as experiment, refers to processes which result in different possible outcomes or observations. The term equally likely conveys the notion that each outcome of an experiment has the same chance of appearing as any other. Probability is the ratio of the number of favorable cases to the total number of equally likely cases. If probability is denoted by P, then by this definition, P is equal to number of favorable cases by total number of equally likely cases. Symbolically, if an event A can happen in A ways, out of a total of n equally likely and mutually exclusive ways, then the probability of occurrence of the event is denoted by P or PR of A is equal to A by n, and the probability of non-occurrence of the event given by Q is equal to PR probability not A is equal to n minus A by n or B by n. 1 minus A by n or 1 minus P or 1 minus PR of A is equal to non-occurrences of the probability. This is how you will come across about the classical or priori theory of probability. Since the sum of the successful and unsuccessful outcomes is equal to the total number of events, we have A plus B is equal to n. Dividing by n, A by n plus B by n is equal to 1. So that P plus Q is equal to 1. Okay, this is about the classical approach. Now I am going for relative frequency theory of probability. The probability of an event can thus be defined as the relative frequency with which it occurs in an indefinitely large number of trials. If an event occurs a times out of n times, its relative frequency is a by n. The value which is approached by a by n when n becomes infinity is called the limit of the relative frequency. Symbolically, P of A is equal to limit A by n, where n is equal to n goes to infinity. The estimate of P of A can be written as if it if it were actually P of A, and the relative frequency definition of probability may be expressed as P of A is equal to A by N. In the relative frequency distribution definition, the fact that the probability is the value of which is approached by A by N when N becomes infinity emphasizes a very important point. The two approaches, classical and empirical, though seemingly same, differ widely. In the form of P of A and A by N were practically equal when N was large, whereas in the later, that P of A is the limit A by N as N tends to infinity. In the second approach, the probability is the limit of the relative frequency as the number of observations increases indefinitely. Okay. The probability obtained by following relative frequency definition is called a posterior or empirical probability as distinguished from a prior probability. A priori probability is encountered in problems dealing with games of chance. A priori probability is deductive in nature, that is, from cause to effect based on theory. On the other hand, probability derived from past experience is called empirical probability, used in many practical statistical problems. Now, this is the second method of probability. Now we are going for personalistic view of probability. The personalistic approach is steadily gaining strength. The personalistic theorists regard probability as a measure of personal belief in a particular event or proposition. A statistical decision theory In statistical decision theory, the personalistic concept emphasizes the fact that since probability of an event is the degree of belief or degree of confidence placed in the occurrence of an event by a particular individual based on the evidence available to him, different individuals may differ in their degrees of confidence even when offered the same evidence. This evidence may consist of relative frequency. This, this evidence may consist of relative frequency of occurrence data and any other quantitative or non-quantitative information. Persons might arrive at different probability assignments because of different in values, experience and attitudes, etc. The personalistic approach is very broad and highly flexible. It permits probability assignments to events for which there may be no objective data or for which there may be a combination of subjective and objective data. One has to be very careful and consistent in the assignment of these probabilities, otherwise, the decisions made may be misleading. This is about personalistic theory of probability. Next, axiomatic theory of probability. When this approach is followed, no precise definition of probability is given. Rather, we give certain axioms or postulates on which probability calculations are based. The whole field of probability theory for finite sample spaces is based upon the following three axioms. The probability of an event ranges from 0 to 1. If the event cannot take place, its probability shall be 0, and if it is certain that is bound to occur, its probability shall be 1. This is about axiomatic probability. The probability of the entire space is 1, that is P of S is equal to 1. If A and B are mutually exclusive events, then the probability of probability of occurrence of either A or B, denoted by P A union B, shall be given by A union B is equal to P of A plus P of B. Now we are going for the importance of probability. What is the importance of probability? Okay, first one, it has been developed and employed to treat and solve many weighty problems. First one is. Second one is, it is the foundation of the classical decision procedures of estimation and testing. That is the second one. Third one is, it is concerned with the construction of econometric models with managerial decisions on planning and control, with the occurrence of accidents of all kinds and with random disturbances in an electrical mechanism. That is the third one. Fourth one is, it has become an indispensable tool for all types of formal studies that involve uncertainty. That is the fourth one. And fifth one is, it should be noted that the concept of probability is employed not only for various types of scientific investigations but also for many problems in every day-to-day life. This is the fifth one. And now we are going for the terminology of probability. Now we are going for the terminology of probability. Okay, this terminology of probability I am going to take tomorrow. So I'm stopping here, and if anyone wants the online classes, I'm going to give my cell number 9849238902. Okay, those people who are interested, they may contact to this number, and don't forget to subscribe to my channel. So it is nothing but an inspiration to me. Okay, even though I take some days gap, but I'm back. Okay, so please note this and try to subscribe to my channel. Thank you.